All right, ladies and gentlemen, it's just going to be a short pre-calc video today, just giving you some more examples, more strategies to think about. And if you want to at any time pause this video and go and try the identity and then come back and watch it, that's also a great idea. So first, let's just start out with our three Pythagorean identities. These are important because whenever you see something squared, you can think, do I have a Pythagorean identity that can relate those two terms? So this one relates cosine and sine and 1 together. And then if we had divided everything by cosine, then we got another Pythagorean identity that was 1 plus tangent squared theta equals secant squared theta. So now every time I see tangent or secant squared together, I think, well, can I relate them together and rearrange this Pythagorean identity in order to simplify it? And then last but not least, we have cotangent squared theta plus 1 equals cosecant squared theta. So here's one that relates cotangent squared and cosecant squared. So right away, I see that I have secant squared and 1 in my first identity I want to verify. Do I have an identity that has secant squared and 1? And I do. I have this identity right there. And if I took this identity, 1 plus tangent squared theta equals secant squared, and I subtracted 1 from both sides, I could see that that identity, when I rearrange all the terms to make it like what I see in my one that I want to verify, that I get tangent squared equals secant squared theta minus 1. And because I'm trying to go from tangent times this to tangent cubed, I'm going to substitute that in because they're equivalent. So we have tangent of theta times tangent squared of theta equals tangent cubed of theta. And when I multiply these two terms, I get tangent cubed theta equals tangent cubed theta. And vice versa, you could work backwards too if you needed to. All right, so there's that one. Here's everything that we used. So if you wanted to pause and get your notes. I don't like to let these videos go too long because they take forever to process. All right, here's identity number 2. And so again, if you want to pause this video and try verifying it on your own and then come back and watch, that's a great idea as well. But I'm going to tell you that I'm going to start with my first strategy of changing everything into cosine and sine, and then I'm going to find a common denominator for this. And I know I need to change everything to cosine and sine because I want cosine. So I know that cosecant is really just 1 over sine. And then in my denominator, cotangent is cosine over sine. And tangent is sine over cosine. And we want that to equal cosine. All right, so you might be thinking this didn't make it any better. But down here in my denominator, I can find a common denominator. This one has sine for a denominator, that cosine. I want a common denominator of sine times cosine. So on this side, I'm going to multiply by cosine over cosine, and this side by sine over sine. And that's going to help me find a common denominator. So then I have 1 over sine all of that is going to be divided by cosine squared plus sine squared. And I'm just going to combine these terms because now I have a common denominator of cosine times sine. So the step in between, really right here, you could have said this was cosine squared all over cosine times sine plus sine squared all over cosine times sine. So that's kind of the intermediate step. You go here, and then you go there. All right, so now here in my denominator, I still can't do anything really with that 1 over sine in the numerator, but I have squares. And so now I think Pythagorean identity, because it's cosine squared plus sine squared. Do I have a Pythagorean identity that I can use to simplify those? And I do. My most common Pythagorean identity, cosine squared plus sine squared equals 1. So all of this right here is just going to be 1. So we're going to simplify that to be 1 over sine, still in the numerator. But now I have 1 over cosine times sine. Much more simple. And I want this to eventually equal cosine. So now it's just simple division of fractions. So this is going to be 1 over sine times cosine times sine over 1. We want that to equal cosine theta. And when we multiply these through, my sines cancel out, and I do get cosine theta equals cosine theta. Again, so let me center this. So if you guys need to take notes, you can pause and take notes here. Okay. So these are just giving you some new strategies. So we've had to find common denominators before, but we didn't have to change both terms, just one. So now we're changing both. And then our last identity, you might want to try this one again on your own, is cosine squared theta times tangent squared theta minus secant squared equals negative cosine squared. And I see I have these squared terms in here, and so I want to take this tangent squared minus secant squared and go back and look at my 3 Pythagorean identities, and I have this one. That relates tangent and secant. And so if I subtract secant here, because I want to get it to look like what that does, I'm going to have 1 plus tangent squared theta minus secant squared theta equals 0. But now I want to subtract that 1. So I'm just manipulating something I know, this Pythagorean identity, to match what I have here. So now I can see that tangent squared minus secant squared equals negative 1. So all of this right here, I can just substitute in negative 1. When I multiply those, I get negative cosine squared equals negative cosine squared. All right, so let's zoom out so you guys can see. This was the one above. All right, that's it. So think about those. Look back at some of the strategies that we've used when trying to do your work for this evening, and come with questions on Thursday, Friday.